Good morning, everyone. I'm Chaitanya. My roll number is 24011A0520, and I'm from CSC Regular. Our teacher is G. Raju, Assistant Professor. Today, I'm going to explain three problems on first order RC circuit and a little bit of what RC circuit is. So, RC circuit is a special type of circuit that has a resistor and a capacitor. These are the two main components of this type of circuit, and these can be connected in either series or parallel. This circuit will consume energy because of the presence of a resistor in the circuit. We know power is consumed across the resistor, and so the circuit can be driven by either a voltage source or a current source. We can use either of them for the source for the RC. The capacitor in the circuit will store energy by charging and discharging, which will show the change in time behavior of the circuit. So we can observe the changes across the capacitor while charging and discharging of the circuit. And there are few equations involved related to the RC circuit. That is the time constant of the RC circuit, which is tau equals to resistance into capacitance of the capacitor. And RC circuit charging, during the RC circuit charging, the voltage across the capacitor can be said as V naught into 1 minus e power minus t by RC, and I equals to I naught into e power minus t by RC. And during the discharging of the RC circuit, voltage across the capacitor, the equation of the voltage across the capacitor is V naught into e power minus t by RC, and I equals to I naught into 1 minus e power minus t by RC. And this is when resistor and capacitor are connected in parallel, and here resistance and capacitor are connected in series. And this is a diagram for the circuit of RC, series RC circuit. This is parallel RC circuit, and these are few graphs related to the RC circuit. And we can say, so here the charge across the capacitor, the voltage across the capacitor is increasing with the increase in time. Here the current is increasing across the resistor. Here the voltage is decreasing across the capacitor with the increase in time. These graphs can be observed when the circuit is charging or discharging. So the first problem is an initially uncharged 8 microfarad capacitor is placed in series with a resistance of 8 ohm and a source of 12 voltage. And they are asking to find the initial and final voltage across the resistor and the initial and final voltage across the capacitor. So this is the circuit as you can see. So the first question, the initial voltage across the resistor. Here the voltage source is of 12 voltage and the capacitor is of 8 microfarad and the resistor is of 8 ohm resistor. So since during the initial conditions the capacitor acts as a short circuit, the voltage across the resistor is equal to the voltage of the source. Therefore we can say the initial voltage across the resistor is 12 volts. This is 0 plus indicates it is the initial conditions after we close the switch of the circuit. And in the same question, we have to find the final voltage across the resistor. So since during the final conditions, the capacitor acts as an open circuit, the voltage across the resistor is 0. Since there is no current flowing in the circuit, so there is no voltage drop across the resistor. So the final voltage across the resistor is 0 volts. The initial and final voltage across the capacitor. The initial voltage across the capacitor is 0 since it acts as a short circuit. There is no voltage drop across it. Since it is a short circuit, there is no voltage drop across it. So the initial voltage across the capacitor is 0 volts. The final voltage across the capacitor is the source voltage since during the final conditions, the capacitor acts as an open circuit and there is no current flowing through it. So there is voltage drop across the resistor. Therefore, the final voltage across the capacitor is 12 volts. So the final voltage across the capacitor is 12 volts since In the final conditions, the capacitor acts as the open circuit and the whole voltage gets settled at the capacitor only. So this is the first problem, and which mainly focuses on the concept of RC circuit and like the theoretical part of it. So we're going to deal with a little more complex thing of it. The problem number two is a 9 voltage battery is used to charge a 4 microfarad capacitor through a resistance of 100 ohms. The initial current through the circuit is, and the final charge on the capacitor of completely being charged, the time it takes for the capacitor to reach 96% of its maximum charge. They're asking us to find the all of them, the three of them. So first, if we look at the circuit, there is a 9 voltage source connected to the RC circuit, and the capacitance of the capacitor is 4 microfarad, and the resistance is 100 ohms, and it equals to 0. The switch is closed. So, first of all, if we calculate the time constant of the circuit, which is RC, 100 into 4 into 10 power 6 microfarad, we get 0.4 milliseconds. So, the first question, the initial current through the circuit. Since capacitor acts as short circuit in the initial conditions, the initial current through the circuit is I equals to V by R. V is 9 as we know and resistance is 100. So the initial current flowing through the circuit is 0.09 amperes. The final charge on the capacitor after completely being charged. So since, as we know, Q equals to capacitance into voltage, that means charge across the capacitor is equals to C into V, Q equals to C into V, and we know the value of C. And in the final condition, capacitor acts as the open circuit. So there is no current in the circuit, hence there is no voltage drop across the resistance. The whole voltage at the source gets accumulated at the capacitor. So the voltage across the capacitor is 9 volts. Voltage across the source equals to voltage across the capacitor. Therefore, VC equals to 9 voltage. As we know, Q equals to C into V, 4 into 9 equals to 36 microfarad. Since capacitor is in microfarads, it is 36 microcoulombs. So the final charge on the capacitor after being completely charged is Q equals to 36 microcoulombs. And the time it takes for the capacitor to reach 96% of its maximum charge. We need to find the time taken by the capacitor to reach 96% of its maximum charge. What can be the maximum charge of the capacitor? So we know Q equals to CV. Q will be maximum when C is constant. Q will be maximum when V is maximum. And V can be maximum at the final condition, which is V equals to 9 volts. So Q equals to the equation of the charge is Q equals to CV naught into 1 minus e per minus, sorry, 1 minus e per minus t by RC. And the maximum charge is 36, which is C into V. We can either say, or we can even write it as C into V naught. They have asked for the time it takes to reach 96%. So 96% means 96 by 100 of CV naught equals to CV naught into the equation of the, we are equating to the equation of the charge in the circuit. And this is a charging RC circuit as we know. So when CV naught gets cancelled on the both sides and we get 96 by 100 equals to 1 minus e per minus t by RC. When we further solve it, we get t equals to 1.288 milliseconds, which is nearly equal to 1.3 milliseconds. Hence, it takes 1.3 milliseconds for the capacitor to charge to the 96% of its maximum charge. So, the capacitor, it means it takes 1.3 milliseconds to charge up to 96% of 36 microcoulombs. This is problem 2. So, if you move to the next question. So, the third question is a 5 microfarad capacitor is charged to 12 volts and then connected to a 400 ohm resistor in series. That means a capacitor is of capacitance 5 microfarad and it is already charged to 12 volts. It means it has the voltage of 12 volts with it, and it is then connected to a 4 volt 4 ohm resistor in series. That means it is a case of discharging of the RC circuit. So find the time constant of this RC circuit. The time constant of an RC circuit is R into C. The value of R is 400 and capacitance is 5 into 10 power minus 6. There's a mistake here, but so it is 2 milliseconds. The initial charge stored on the capacitor. The initial charge stored on the capacitor is Q equals to C into V. It already has a 2 voltage with it. So Q equals to 5 into 12, which is 60 microcoulombs. This is a case when the capacitor is discharging. The before two problems were on charging of the capacitor, and this is when capacitor needs to discharge the voltage which is associated with it to a resistor or something which is connected to it. Since in the initial condition capacitor is reluctant towards the change in voltage across it, we can say Q equals to C into V and we can put the value of V as 12. The initial current through the resistor. When a capacitor in an RC series circuit is discharging, the current at any moment is determined by using the formula I equals to I naught into e power minus t by tau. Tau is RC, and when we substitute the values where I naught equals to V naught by R naught, which is the maximum voltage 12 associated with the capacitor, and R naught is 400. And we get I naught equals to 0.03 amperes. So the initial current through the resistor is 0.03 amperes. Since at the beginning, the charge on the fourth question is the charge on the capacitor after 3 milliseconds. They're asking us to find the charge on the capacitor after 3 milliseconds. So in the third question, at t we have substituted 0 because they have asked it to find the initial current. And in the initial conditions, we know t equals to 0. So moving on to the next, we have the charge on the capacitor after 3 milliseconds. The equation of the charge is Q equals to Q naught into e power minus t by tau. So they are asking us to find the charge on the capacitor after time t equals to 3 milliseconds. We know the equation of charge is Q equals to Q naught into e power minus t by tau. Here at the place of t, we need to substitute 3. And tau we know it is 2 milliseconds. Since after 3 milliseconds, substitute t equals to 3. And the charge on the capacitor after 3 milliseconds is, we know Q naught is 16 to 10 power minus 6. And here e power minus 3 by 2. With the further calculation, we can get Q equals to 13.38 microcoulombs. So this is the final charge on, it is the charge on the capacitor after 3 milliseconds of the discharging RC circuit. So these are the three questions on RC circuit, discharging and charging of the RC circuit. Thank you.